I think if everyone wants to take their seats, we'll go ahead and get started. So really pleased to have you all here at the Plant Sciences Building, which is the home of the Plant Sciences Initiative. And we're very excited to have you here for our mashup. So our mashup series, the whole goal behind it is that we want to have a platform where we can have academia and industry interactions. We also, forward, there we go. We also want to highlight and thank members of our innovation hub we have in the building. So on the third floor of this building, we have a spot called the Innovation Hub where we invite companies to join as members. And if they're members, that's their location in the building for interactions with our students and faculty. And so we're really excited that we have now 12 companies that have joined the Innovation Hub. And so the Mashup series is also to be able to allow those companies to have the stage for a bit and give a talk on a topic of their interest. If you're interested in learning more about the Innovation Hub, just come find me. I'm happy to give you more details about the hub and what comes with the membership. We're really excited that today our industry partner that we're highlighting is Agerpoint, and we have Bobby Vick from Agerpoint here. They'll be giving a talk in a moment. And I also want to mention that we are going to have another mashup coming up on March 27th. Details are still in the works. We have some ideas. And so I'll be sending out some news about that as soon as we have the lineup figured on out. We're also delighted that in the audience today, we have the Eisenhower School, students from the Eisenhower School. Could you raise your hand if you're from the Eisenhower School? Yes, thank you so much for being here today. I'm glad it worked out that you were here already to visit, and it was perfect. And so also I'm curious, Mashup, the whole point is to get people from industry and academia together. So raise your hand if you're from academia. NC State, okay. Now raise your hand if you're from industry. Awesome. So that's the whole point. We want to get people here from all different sectors and have them interacting with each other. So to first start off, I'd like to invite one of the students from the Eisenhower School to come on up and tell the audience a bit about their class and what the Eisenhower School does. Thank you so much.
Good afternoon, everybody. Can you hear me okay? I'm much more of a walker, so I'll try to project. Please raise your hand in the back if you're having a hard time hearing me. First, just let me start by saying a truly heartfelt, massive thank you for the team hosting us today. We are absolutely thrilled to be here. The afternoon has just been so rewarding, so huge thank you. So many of you are probably thinking, what is the Eisenhower School? So I'm going to quickly break it down for you all. 3 topics I want to cover, a bit about our school, the background, who is in our class, because I think that's something that's really unique and distinguishes us. And then lastly, I'll close by, the group of us here, we're just a representation of our class. So I want to talk about our group and why we're here. So first, the Eisenhower School, as you probably saw up here, we are just celebrating our 100th birthday. The school started in 1924 as a response to logistical and resourcing issues that came up after World War I. So the school then later on, became named after President Dwight Eisenhower. Hence what we call it Eisenhower School today. And the school's really focused on 3 big areas. First, building strategic leaders. Secondly, on national security, as you can imagine per our name. And then lastly, resourcing. What does resourcing mean? That means we're really focused on the health of the defense and national security industrial base. That actually makes us really unique because we're a DoD school and we're a senior service school, but we're the only school that is focused on that resourcing piece. There's a lot of other senior service schools that focus on national security or building strategic leaders across the defense ecosystem, but we're unique in that we really focus on the health of the defense industrial base. Which leads me to my second point on the composition of our class, which I'm really excited about because there's 4, categories of people in that class. First, as you can imagine, because it is a DoD focused school, it is comprised of senior officers. So think for those of you with a military background, like 05, 06 level, and rising leaders in DoD. So representing all the services, Space Force, Air Force, Navy, Army, Marine Corps, Coast Guard. as well as intra-agency. So we have representatives from State Department, Department of Energy, USAID, and many others that are represented in our class. Third group is amazing international students. So we also have international military officers across the world. And then last category, which I'm a part of, and I think what makes us pretty unique is we also have private sector fellows. So I am not DoD, I am not interagency, I don't work for the government, I work for McKinsey & Company. I'm a consultant who gets to have the honor and privilege of getting to attend Eisenhower School. And then leads me to my last and third piece of, why is our group here today? Well, so our class is comprised of 286 students. You can imagine there's not 286 of us here today. There's 18 of us, and our whole class of the 286 are divided into 20 different seminars, and each seminar is focused on a key industry that's vital to the national security defense industrial base, right? So our particular seminar is focused on biotechnology. And so as part of the work that our seminar is doing, we're doing a lot of research, really understanding what is the current state of biotechnology industry in the United States, where other potential vulnerabilities that we should be flagging for national security leaders. So this could all culminate in our capstone project at the end of the year, which is going to be a research paper coming up with potential some recommendations that we'll be able to share with leaders in the national security space. I hope I covered everything. I'm sure there's probably some things that I missed. I don't know if you want me to take any questions, or happy to also continue the dialogue on who we are and what Eisenhower is at the happy hour.
Questions for Ellen?
I have a question, if that's okay.
Oh, absolutely.
I'm just curious how you see food in the discussion around national security from the Eisenhower school perspective.
I'm happy to jump on this one, but I'll also turn to my classmates to see if anyone has a I think it's a hugely important piece, right? I mean, if we think about food security and what that could mean, not just being able to feed our own troops for defense, but also what could it mean for tensions, national security relations with other countries over food insecurity. So that's one way we would look at it. I don't know if anyone has anything else they would.
I would just say, don't think of national security as like a military thing. National security is how this nation survives. So food is vital to how this nation carries on forward and survives.
And I mean, human capital obviously is a hugely important piece of the national security ecosystem. So if we bring it back to food insecurity, what we learned about in our great presentations earlier is just like nutritional insecurity, right? And what does that mean for the health and well-being of the human capital that we need to be able to be part of the national security ecosystem? Any other questions? Well, I'm very excited to continue talking with everyone at the happy hour. Thank you.
Yeah.
Thank you so much. All right, so now we'll get into the main part of our program. So today's topic is on data-driven agriculture, and we have two speakers. So Dr. Cranos Williams is going to be our first speaker. Dr. Williams is our NC PSI Platform Director for Data-Driven Science, Agriculture, and he's also a Goodnight Distinguished Professor in the Department of Electrical and Computer Engineering. So Dr. Williams, I'll invite you on up here.
All right, good morning all. Oh, it's not morning. Good afternoon all. It's been a long day. All right. So as Kathleen said, I am a professor in the electrical and computer engineering, but with also a partly part-time appointment in the plant and microbial biology department. And today I'm just going to give a presentation, really starting to talk about what we're doing at the PSI around data-driven agriculture. So I think the problems around agriculture and the problems around food security, as was mentioned earlier, is apparent. 70% more food is going to be needed for human consumption by 2050 due to the increase or expected increase in the global population. And even today, with the current population, we have some 690 million malnourished people and up to 2 billion people affected by food insecurity. This, coupled with dramatic and drastic changes in the weather, really causes systematic problems in terms of our ability to generate food reliably. Now, with the advent of things like IoT devices, sensors, and the ability to not only acquire data, but analyze data, we see an opportunity here where we can actually couple not only the things that we're able to acquire, but couple that with strategies for understanding and making interpretations from data to make extreme to advance knowledge in this particular area. So here I'm going to really talk about today how we can look at data-driven and computational approaches and the potential it has for transforming how we look at agriculture. And this brings me to the North Carolina Plant Sciences Initiative. So as you guys know, the vision of the Plant Sciences Initiative is to create a healthier and sustainable and more prosperous future through plant sciences innovation. And the goal here is to be able to accomplish that by looking at interdisciplinary team-based science research and incorporating knowledge from several disciplines to be able to address some of the most challenging societal problems around agriculture. The PSI itself, in terms of our leadership structure, is led by Adrian Percy. And under this, we have a set of platforms, which I'll define in a second. We have certain platforms that really focus on fundamental and translational research, and platforms that focus on training and engagement. The platforms that are associated with fundamental and translational research are the Plant Improvement Platform, the Resilient Agricultural Systems Platform, and the Data-Driven Plant Sciences Platform. The first being led by Ross Sidzani, the second being led by Chris Ruberg-Horton, and the third being led by myself. In terms of training and engagement, we have Terry Long, who leads the Education and Workforce Development Platform, and Rachel Van, who leads the Extension, Outreach, and Engagement Platform. Now, all of these platforms essentially work together, really trying to push this connection between foundational and translational research and how it can potentially impact not only the stakeholders of North Carolina, but stakeholders around the world. But what I'm going to focus on today is really the data-driven plant sciences platform. Give me 1 second. I cannot see. This is why I brought these up here with me. All right. So this platform is really focused around a couple of different things. Really focusing on identifying and putting in place the resources or personnel to really drive interdisciplinary research and drive our ability to accelerate data-driven plant sciences in interdisciplinary projects. We are also looking at developing the infrastructure to be able to do this. This includes the development of what we call the makerspace, which is housed in this building on the 3rd floor. And this makerspace is used to develop prototyping sensors for acquiring data at various levels, within the lab, within the greenhouses, and within the fields. We're also looking at opportunities for data management and computing. And this is also the place where we are administering what is called the North Carolina Ag Analytics Platform, which I'll talk about a little later. So the central vision of this platform is to serve as the data acquisition, data management, and data analytics catalyst for discovery, innovation, and translation of plant sciences research. To be able to accomplish this vision, we're really focusing on 3 core platform goals. One focused around sensor development and automated data acquisition, one focused around data management and computing architectures, and one focused around training, outreach, and education around training opportunities and exposing or advancing training opportunities and accessibility of data science tools for plant scientists and agricultural researchers. In terms of goal 1, here the goal is to be able to lead the development of the NC PSI makerspace and use it as a test bed for technology innovation and discovery. In this case, as I mentioned earlier, the makerspace is a 1,050 square foot laboratory that's housed on the 3rd floor of the Plant Sciences building, which you're in now. It is the only makerspace lab on NC State's campus that is exclusively dedicated to the support of interdisciplinary research projects in agriculture. It provides not only the equipment to be able to develop and prototype such sensors, but also led by the Makerspace director, Andrea Mendoza, our Makerspace director. She provides consultations and technical support for prototyping, for the prototyping stage of research devices, as well as access to equipment in core areas. In terms of the capabilities and technological resources, we have equipment for electronic prototyping, digital fabrication, and machining tools and equipment. And we've hosted and supported projects at various levels, from fabrication only to design consultations to full end-to-end service. Our next goal is really focused around data management and cloud and on-prem computing. Really focused in terms of maintaining a structure and infrastructure for not only the data acquisition, but the data management and analysis associated or around large-scale plant sciences projects. And really focusing on those core components of storing, analyzing, and maintaining large data sets from these projects. As part of this, we are facilitating the North Carolina Ag Analytics Platform. This platform is led by Program Manager Brad Lewis, and it is led or created through legislative funds that was provided to North Carolina State. And the goal of this platform is to develop a platform to use data collection, management, and analytics that will improve agricultural systems and agricultural profitability for North Carolina stakeholders. And the expectation is to be able to impact aspects of sustainability, profitability of agricultural systems within the state, to be able to increase research grants secured by researchers at the institution, to facilitate student and faculty recruitment, and to ensure or enable collaboration with private farms. This is done in collaboration with SAS and North Carolina A&T State University. As part of this platform, we're really strategizing around putting in place the infrastructure that's necessary for automated data ingestion, for data management across heterogeneous agricultural data sets, for putting in place both the on-prem and cloud computing resources for AI and ML compute, and keeping in mind here that the endpoint is always going to be the stakeholder. So identifying ways and opportunities to be able to deliver these solutions directly to the stakeholders, whether that's through web-enabled dashboards or other forms of information that help stakeholders better make their decisions. So the goal of this platform is to directly support these types of projects. So some examples of the types of projects that is supported by the Ag Analytics platform is, for example, Sweet Apps. Sweet Apps is a project that is led by myself in combination with several other researchers that really focuses on minimizing waste and maximizing value across the sweet potato value chain. And this is done through strategies of sensor development and analytics and discovery. The goal here is to develop novel imaging and sensing systems across the value chain such that we can then acquire data and extract relationships that help in the decision-making for stakeholders. As I mentioned earlier, this project is led by myself, Dr. Kara Grieger, Dr. Mike Kudinoff, Dr. Danny Jones, Dr. Craig Yensho, and Dr. Mike Boyette. It's split up into 4 different parts, one that's focused on stakeholder engagement, one that's focused on sensor development, one that's focused on data management, integration, and analytics, and one that's focused on workforce development and translational research. And I'm just going to briefly talk about some of these different parts. As with most PSI projects, the stakeholder becomes the center of how we try to develop technologies and make decisions. So as part of this project, one of our initial goals was to be able to engage stakeholders and understand their needs, perspectives, and incentives and barriers, as opposed to just creating technologies based on our own interpretations. So one of the things that we found here were, one, their inclination in terms, or their what I would call hesitation in terms of not only data generation, but also data sharing. Also, we were able to identify ideas of who they are willing to share data with and who they're not willing to share data with. And we're also able to define some of the pain points that they have in terms of their decision-making across the value chain. We also looked at developing various sensing technologies at various levels. So things like in-field phenotyping, looking at imaging systems that allow us to make estimates of size and shape distributions just from top bin images, and even imaging systems that allow us to image and quantify all sweet potatoes that are going through the packing facility. We're also able to develop portable optical scanning systems that allow us to test new or novel imaging technologies as well. Now, the idea here is that we're acquiring all of these data along with the provenance data that they are able to acquire in their track and trace system, and trying to identify ways to be able to not only merge those data, but extract relationships across them. This requires a tremendously and sometimes annoyingly complex data storage and management strategies for these data sets, enabling that we have not only access to those data as researchers, but they have access to those data as the data owners. Looking at and developing machine learning approaches for, again, tackling some of the more difficult issues, such as classification of sweet potatoes in terms of their value, or even making connections across provenance inputs like soil, weather, planting date, fertilizer application, et cetera, and connecting that to output characteristics that are tied to value, like shape, size, curvature, length to width ratio. But then again, the important part here is delivery. Being able to transform all of the insights that we're able to get from these approaches into usable, accessible dashboards that they have access to. So all of these things that we've been able to do. Training has been an important part of this project as well, training upwards of over 6 undergrads, 9 graduate students, and 4 postdocs. And also being able to use the data that we have to expand the type of questions that we're asking, making sure that what we're doing is translational for the stakeholder, such as looking at questions like optimizing time for harvest, using in-ground modeling of sweet potato growth, the development of machine learning to figure out factors that affect profit, and even narrowing down provenance location to specific parts of the field so that we can use that to help inform management decisions. Other projects that have been supported through the Ag Analytics platform include BeanPack, which is a soybean dashboard for soybean growers. This project is led by Rachel Van, and I myself have worked with Rachel Van in terms of translating some of the research data that she's been able to acquire to machine learning models that provide input for soybean growers in terms of when are the best dates to harvest. This model reflects specific locations within North Carolina and differentiates the best planting date based on that location. So this is something that Rachel led, and we were able to put together this model and actually put together a front-end dashboard that could be accessible to soybean growers. And this model and dashboard is currently live. Other projects that are emblematic of what we would want to support within the this platform includes the NEMA AI project, which provides tools for the automation of nematode assays analysis to provide faster turnover, allowing farmers to make more robust management decisions. And development of optical sensing tools, similar algorithms to what we developed for sweet apps, but applying this to other crops such as peanuts to be able to aid in peanut breeding. This applies a novel grading method using imaging and machine learning approaches to provide more precise phenotyping systems for improving genetic mapping of pod and seed size within the North Carolina State Peanut Breeding and Genetics Program. One of the aspects here as well as part of the data-driven plant sciences platform is team growth. We want to make sure that we are able to identify faculty who are interested in pursuing these types of interdisciplinary research opportunities. And through this, we've participated and in some cases led some of the team ideation events that we've had at the PSI. This includes the Connecting to Grow event that we had in 2023, focused around sensors in agriculture, and our engagement with folks like Rachel Van in the 2024 Connecting to Grow event, Automation in Agriculture. In particular, that first Connecting to Grow event led to seed funding opportunities, which were jointly held between the PSI, a interdisciplinary group called ICONS, Institute for Connected Sensing Systems, and the Keenan Institute. This led to the funding of 2 novel sensors in ag projects, one led by Ricardo Hernandez, creating synergy with agrovoltaics, and one led by Wenye Wang, sensing and measuring of underground crops. Okay, so we've talked about sensing and sensor development. We've talked about data analytics and facilitation of data acquisition, management, and analysis, but we can't miss one of the most important parts here, which is training and education. One of the goals of this platform is to be able to increase accessibility in data science tools and training for plant scientists and agricultural researchers. And one of the things that we're doing as part of the North Carolina Ag Analytics platform is really promoting education around different forms of training in data science. So for example, the existence and working with SAS, trying to promote no-code-like environments like SAS Viya for individuals that don't necessarily have Python backgrounds, but still want to be able to empower themselves and their research groups through data analytics. Brad has been instrumental in leading several training sessions or helping to facilitate several training sessions around this, partnering with different groups and training different groups such as the Center for Environmental Farming Systems, the Center for Integrated Pest Management, and also working with the Food and Animal Initiative. We've also identified other projects that would work directly with SAS to be able to further the advancements of their project. And in April 2025, we're actually hosting an AI 101 workshop for extension agents to really get into the hands of these extension agents knowledge and awareness of some of these data analytics tools so that we can, in a sense, train the trainer and they can facilitate the distribution of that information to not only other agents, but also the farmers and growers that they interact with. The training doesn't stop there. We are also very much interested in cross-training of students in various areas of data science. We work with Terry Long, who's the platform director of the Workforce Development Platform, to identify interns for USDA ARS, where USDA ARS are funding AI internships. This was something that started back in 2023. 5 were funded in 2023. I think 5 were funded in 2024. And the increased interest in this program has just bloomed, where last year we had over 100 applicants. And this year, I think Terry's probably anticipating more. Sorry, Terry. We've also worked with folks like NVIDIA to host AI and ML workshops. We also host a yearly hackathon. These hackathons include or try to recruit students from across different colleges to work in different areas that promote, again, translational and experiential experiences in using data analytics sensors and applying it to agriculture. Tracks like this include a 3D printing track for ag, an ML for ag advanced track, which is sponsored by Bayer, a real-time monitoring track, and even a phenotyping track. We also are interested in partnering with others. So for example, with Dr. Danny Jones, who leads and heads the CAL's Ag Data Science Certificate, identifying ways to incorporate tools like SAS Viya into those classes that's associated with the certificate, and closely working with her to identify new opportunities. There are also workforce development opportunities, such as a partnership between NC State and North Carolina A&T, which is funded through a USDA Next Gen project. And through this, we're actually funding traineeships for PhD students. So these include 1-year fellowships for PhD students where they're fully funded and tuition is paid. This also includes undergraduate research opportunities for students both at NC State and North Carolina A&T, and traineeships for trainees in the makerspace. And that actually is also funding the AI 101 workshop that we have planned in April. And then there's the recently funded NSF NRT, which is led by, again, Terry Long, Grad Aid for Ag, which really focuses on identifying how AI and the use of AI can seamlessly link connections between fundamental research and more applied research. And then we're also interested in new opportunities. So there's an emerging genomics editing center for sustainable ag that is being started here. And for example, identifying opportunities where we can put in place the infrastructure to support the center from a computing standpoint, and also new opportunities for AI research, such as, for example, utilizing AI for finding novel regions of gene sequences that influence things like translational efficiency. So this last slide just kind of gives you an overview again of the data-driven plant sciences platform. Again, I've talked a little bit about the resources, didn't talk as much about some of the individuals that are putting those things in place, but there are a lot of them. I talked a little bit more about the infrastructure. I work with the NC Ag Analytics platform and how we are using all of these things to try to really accelerate data science in these interdisciplinary projects. And with that, I would like to end my presentation and open the floor up to any questions.
You mentioned for some of the projects, the stakeholders had concerns about data sharing and what could and couldn't be sharing. Is it more a concern about sort of the end products? So what of the data that you guys contribute, or is it the process and procedures and sort of that insider knowledge of how you're doing and collecting all of that data that was more of a concern?
Good, very good question. I think there's, on one hand, the kind of open-ended question: where does my data go? Who gets to see it? Do my competitors see it? You know, et cetera. And making sure that there, at no point in time, anyone that sees the data could, in some ways, use it against them. I think that was probably the primary concern. There was also concerns in terms of the insights and kind of where do those insights go. And in some cases, they can be almost contradictory. So on one hand, they don't want their competitors to see their data, but they're okay sharing the insights to the broader community. In this case, as long as it's North Carolina. So in terms of sharing information or sharing insights with Mississippi, sharing insights with Louisiana, or even sharing insights internationally, no. So it's kind of like the whole brother or sister thing. You know, you're the only person that can fight with your sibling, but if anybody else fights with them, you jump in. So they are willing to share those insights to promote the community and the business and profitability of North Carolina, but just not outside. So thus, you now have to then create this way of being able to accelerate that, understanding their cultural interactions, and framing that and rolling that into how you not only analyze the data, secure the data, but also how you distribute the results.
Your scientists said about it's 2025, enough data to process into the system.
Okay, so I think the question was, is there enough data in 2025? If there enough data to be able to put into these type of large scale black box types of things to make magic out of? And I would say the answer is, yeah, kind of. So lots of data can be generated. That doesn't mean that lots of data go together. So as opposed to, let's say, large language models, and this is an example that I use a lot. When you have text online, the text is pretty similar across different documents. As long as it's in the same language, as long as the grammar is okay, you can use that information time and time again, you know, on end. And you have billions and billions of examples. With agricultural data, however, there's a lot of context. There's a lot of heterogeneity. Even though sometimes you're taking insights or taking data from the same thing, that is looking at it from many different directions, many different dimensions, and it makes it very difficult to actually put those things together. And I think that's honestly where a lot of the research opportunity lies, to be able to make connections, whether it's semantic or whether it's inferred, connections across the large amounts of data that we have, such that it can fit into some of these modeling strategies. And then in some cases, working with engineers, working with computer scientists to be able to then develop robust algorithms that can take that heterogeneous types of data and actually put it into some sort of model to extract information. So this is honestly where a lot of the work that we've been doing around semantic relationships and knowledge graphs. So for the people that we work with, they have data coming in from purchasing. They have data coming in from our sensors. They have data coming in from the track and trace system. There are small connections between some of these and no connections between others. So we have to identify and put all of those in the same place, draw out, in a sense, a graphical relationship as to where some of the connections are, use those relationships along with our algorithms to then draw insights based on the questions that they have. I need to pack a certain type of sweet potato. These are my customers. This is what I have in stock. What should I do? Which bin should I grab? Which field should I pick from? Those types of questions. So that's where we have lots of data, but we have to strategize in terms of how to best use it.
Data from satellite too.
Data from satellites, exactly. And this is where, again, those data are across different temporal scales. Those data are across different spatial scales. So identifying novel ways to be able to put those together become extremely important.
Thank Dr. Williams again. All right, and you'll have time to talk to Cranos at the mixer right after this. All right, so now I'm going to invite out our next speaker, Bobby Vick with Agerpoint. He is the VP of Solutions Engineering.
Perfect. All right. Well, good afternoon. I am keenly aware that I and a few minutes on the clock are the only thing that stands between you and the mixer, so we'll keep that in mind. But appreciate the opportunity to be here. As Kathleen said, my name is Bobby Vick. I lead the solutions engineering team at Agerpoint, and we're an agtech company. We make software to help with a lot of the logistical part of what Cranos was talking about: the collection of data, the analysis of data, the management of that data, and then the distribution of that data. And I'll keep my talk pretty high level today about some of the different use cases that we are working in, but most of it focused around this particular challenge of how do we make the acquisition of data more feasible, and then what do we do with that data once we have it. So if you'll allow me for a second, I'll kind of step back. If you ask the question of what is data-driven agriculture, if you do a web search of this, you can get a lot of interesting things, but you'll see pictures almost inevitably that have drones in them, sensors in them, maybe augmented reality, C words like drones, sensors, IoT, AI, augmented reality. You get the point here. There's a whole lot of buzzwords that are out there today. I find it intriguing though. What's one of the common threads that you see in the pictures here, despite all the technology that's there? I saw you mouth it, Adrian. It's the human. The person is still a critical part of this. All of this technology is really the crux of the matter is how do we get information more quickly and make decisions from it, and the human being at the center of the loop. And as I think about this, there's sort of information's always been available. Farmers have been making decisions for as long as agriculture's been around. So what is it that we're trying to do? Well, we're trying to obviously make those better. And you can do that in the form of, we can have more information, we can make it faster, we can make it cheaper. And when I hear those terms, it makes me think about the sort of the acronym, or not acronym, but the saying with services. What is it? Good, fast, cheap. Pick any two, but you can't have all three. And I'm not sure if that's true in data and agriculture or not. I think that at least our goal right now is that we can have all three of those, that we can get more information, that we can do it, have it more accessible, that it can be quicker, and that it can be cheaper. So with a lot of these terms, there's a ton of information, or a ton of excitement today, I should say, around artificial intelligence, machine learning. How do we use that in generative AI? I used this in a previous presentation, so I hope you'll just bear with me for a second. I'll use the example of how I interpret AI and sort of where it is in the field of agriculture today through the lens of my son, who's in kindergarten right now. So as a faithful graduate of NC State, native of North Carolina, if you can't tell from my voice, when I ride around with my son, I try to quiz him on what different crops are. So he'll learn, this is what a cornfield looks like, this is what a cotton field looks like, this is what tobacco looks like here in North Carolina. We'll say things like, this is what a tractor looks like, this is what a combine looks like, this is what a sprayer looks like. So in essence, we have trained him on two models. He has a model of what crops look like. He also has a model of what different farm equipment looks like. To use that metaphor with generative AI, I gave him a prompt. I said, okay, so you know, Thomas, what tobacco looks like. You know what this different machinery looks like. Could you draw me a machine that one would use to harvest tobacco? This is what I got. Pretty on par for what you would expect from a kindergartner. I can see some wheels there. There's some, some pointy objects for maybe taking in the crop. It's humorous, but he hasn't quite synthesized the raw models that are there. To take this one step further, though, I said, well, let's try this with real AI. So I put this prompt into a few different AI engines out there. And to be fair, I specifically used tobacco harvester because that's not the same as corn or some of these other things. There's probably many people in this room that don't know what a tobacco harvester looks like. Stand by. This is what real AI gave me. Okay, dump truck with several wheels on it. I like that you probably, if you're not familiar with tobacco, you're like, yeah, I can see that, but that looks a lot like a corn harvester that's maybe stuck in a tobacco field to me. This one is one of my favorites. I'm like, I don't even know what this is, but this is real. This legit came out last night, and this one actually might be the closest thing to what is a real tobacco harvester because it's still very manual today. Other than this, it appears to be an Amish operation or from several years back. But I say all of this just so you are informed. This is what you might see as an automated harvester in Eastern North Carolina if you went out and did see a tobacco harvester today. So the point in all this is we have a lot of information available today. We have been able to make incredible models that are very functional on specific use cases in specific environments. Part of the challenge here is how do we bring this together? How do we make it more synthesized so that it's applicable in a wider array of settings, environments, and use cases? And so with that, I will spend the rest of my time talking through what we are doing at Agerpoint. We are based here in the Research Triangle Park. Our headquarters is over at the Center for Alexandria Center for Agtech in Research Triangle Park. Fantastic facility. Lot of similarities between this building and that building in some respects. But I would encourage you to visit if you have the opportunity to. And I've said this already, but really our focus is working on how do we make field data more accessible? How do we help with the capture of it, the analysis of it, and then management and distribution of that data? And I will focus primarily on agriculture here today, but we work across really two main sectors, agriculture, and within agriculture, meaning the production agriculture, ag R&D space, but also in the nature space. There's a lot of work that's going on in the reforestation, voluntary carbon markets that depend on being able to get, how do we validate that these carbon initiatives are doing what they are saying they're doing? How do we make sure that we are restocking this forest with sustainable initiatives that are in place? And so our company's been around for several years, but where we sort of the transition of it, we started out, we were using LiDAR on the back of ATVs, driving up and down permanent tree crops in Florida and California specifically, so think citrus and nut trees. And we were using these 3D models to generate highly resolved point clouds of an entire citrus grove, give every single tree its own individual address and take measurements from that. We still leverage that technology to today, but we're focusing primarily on using more accessible sensing means. So I would venture to say that every one of you in here probably has a smartphone somewhere on you. And so today we're using things like LiDAR on the phone as well as imaging on the phone to take these high fidelity digital twins of plants as well as other information, audio data, video data in the field, and then turn that into information. Sort of the path to where we see this going forward is continuing to leverage this information and this technology on things like autonomous vehicles. Also providing augmented reality. And it's not just a thing of the future, it actually is here today. So we work with a lot of companies that have farm operations spread out all over the globe. How do we make it so a person, at the management level can see those operations, know what's going on in the field? And in turn, how can we give informed decisions to someone that's, say, pruning a almond tree or a blueberry bush about decisions they might need to make in the field using augmented reality and the sensors that they have at their disposal? So where we are today, we have a mobile application. I'll show you some screenshots from it here in just a second, called Agerpoint Capture. It's available for download from the from the App Store as well as on Google Play. And it allows you to capture data, put it into our cloud ecosystem, and run various models on it. And just to kind of give you an idea of what that looks like, this is sort of the, I'll show you this, and then I'll show you a subsequent slide that'll show you the different phases of this data capture and operation. So you take the phone out, you're gonna feel like you're taking video, because you pretty much are. As you walk around, you're taking video, but in addition to the video, you will get an augmented mesh. If you can see in this tree, for example, that's starting to form a 3D model directly on the phone. And once that gets uploaded into our software, we turn that into the models that you see on the center and the right of your screen. These are screenshots, obviously, but those are three-dimensional models that came from someone walking around a citrus tree, a corn plant, a row of wine grapes. And in addition to forming the 3D models that you see, we actually use things like machine learning to segment out the individual components of that plant. So take the fruit, the leaves, and the trunk of a tree, turn those into individual components, and then take measurements from them, take counts from them, and turn that into information for our customers. All of this resides in a cloud-based platform. So you can see, just like you have your photo album in, say, Google Photos or wherever, Apple Photos, whatever it might be, all of that data resides in a dashboard. You can go into these interactive views. The blue dots in the center here would represent the path that the sensor was moving around the tree. And then we can overlay this with other types of information, be it satellite data, drone imagery, or weather information into a comprehensive spatial platform for managing data over locations, but also over time as well. So that sort of sets the stage for the work that we're doing. I'll give you kind of just a quick run through of some specific use cases and some of the projects that we are working on. This kind of goes through the migration of us as a company as well. This is an example of an R&D farm that we've managed or monitored, I should say, for many years. And this started out, we were doing monitoring literally with an ATV going through it with a LiDAR on the back, generating maps, morphologies, we call them, of each individual tree in that field, and then extracting information from that tree, like the height, the canopy volume, the trunk diameter. Fast forward, we can now do that same type of information using a smartphone today. And obviously you're not going to walk around, say, 10,000 trees. One person's not with a smartphone, but we've embraced the reality that a lot of agriculture is based off of sampling. And there is a certain scalability that comes from just having access to that information in a smartphone in your pocket. Some of the other things that we're doing, not just dependent upon three-dimensional data, is using machine learning to assess early emerging crops. And we're going to be working with a cohort of extension agents in North Carolina this year to test this specifically on corn, cotton, and soybeans. We did this over the last couple of years with a major commercial input provider. And just to give you an idea, we literally walk down, these are plants that are super tiny to see. And it would take an individual a lot of time to get down and physically count them. It's highly subjective and error prone. And we can take literally just a smartphone walking down the side, we're able to capture the videos that you see. And in addition to counting these individual plants, we're also measuring the distance that the phone has moved. So we can translate that into an actual number of plants per acre that are there in the field. And this is the kind of information that right now we're using it in a research context, but where the next phase of this will be is putting this in the hand of a grower or a farm manager to be able to make a decision about, should I replant? What's the status of this crop? How are things progressing forward? As those plants get bigger, we can do things like the three-dimensional analysis you saw on a tree previously, but now this is a row crop. So we're walking down the side of this row of beans. You see a snapshot pulled out from the side there. This is what we essentially create, a 3D profile of this crop. And then from that, we can extract different things like the height of the plant, the color of the plant. And to put that into practice, you and I can look at these are two different plots of beans. Plot A and B, you can see to your naked eye that there's less foliage in plot A. There's more foliage in plot B. The rows are a little bit thicker in plot B. That manifests itself in the numbers that are automatically generated with our software down at the bottom of the screen. So a lot of this is taking what would otherwise be a subjective process and turning it into something that's objective, that's repeatable, and that's not dependent on the person doing the analysis, but it's, depending on the technology they're using. We're also using similar technology to help the crop insurance space. So this is actually not about mobile phones, but this is using data from UAVs. So we use commercial grade UAVs, but I say commercial, but they're the kind that you and I could go buy at Best Buy for $2,000. We use automated software for flying those drones. These are actual crop adjusters that have access to this technology. So they get a report, there's been a wind event in a cornfield. Keep in mind, these corn plants are usually 10 to 12 feet tall when this is happening. You can walk in one corner of the field and see nothing. That doesn't mean that the other half of the field may be completely laying down flat. And so they fly the drone over the field, we turn that into an orthomosaic, and then using machine learning, we're able to very specifically identify where in that field there is damage. And we actually turn that into an automated report, PDF report in this case, out to them that says on each block within that policy, how many acres were identified as damaged. You know, Cranos mentioned that not all data is good data. So part of what we have had to work with over years of capturing this data is training it. And so we don't use the mobile out to go out into the field and actually validate where are spots of healthy corn versus where are spots of damage. You can actually take our application and walk out, it'll track your location, and you can use this to see what the field actually looks like and turn that into a 3D model for reference as well. The last few examples I'll give, and then I will quickly wrap up, is we're also using this for management of fruit and vegetable crops. So there's a lot of interest around how do we make better decisions around supply chain, how do we make better harvest decisions around timing, also just knowing how much harvest to expect. So very similar to identifying individual plants, this is a technology where we're walking along grapes. The left-hand side is the raw imagery. So these are when the grapes are still, they're in the viridian stage, they're still green on the vine. The right-hand side of that image is the classified image that is identifying each pixel that is a grape. That gets extracted into the 3D point cloud that you see on the right. And then we can take samples from across a vineyard and start to make block level decisions about how many grapes are we expecting, how many barrels do you need to secure to be able to harvest this block, you know, several months in advance of when the harvest actually takes place. Another food crop that's near and dear to my heart, this is actually cocoa trees in South America. So we're working with a large food and beverage company that supplies cocoa, obviously from all over the world, or not all over the world, but not from the US. This particular farm is an organization that's building an 8,000 hectare plantation. That's a lot. That's 20,000 acres, if I'm doing my math right, of contiguous production of cocoa. And currently they send out personnel to go through on a quarterly basis, count trees, count the number of pods on trees, and then classify what stage of those pods. That tells them how ready for harvest they are. So we're using cell phones with them to scan those trees, turn it into a 3D model like you see here, but then segment out the different parts of it. And so we can quite literally pull out just the pods from that tree and give them an estimate of not only how many pods are there, but how many pods are going to be ready for harvest this month, as opposed to 2 months later. They harvest these continuously. They're going through every couple of weeks. So it's a really important decision for them to know where their supply is and what the forecast of that supply is going to be. In addition to the yield piece, we're also helping them in making informed decisions around things like disease. So we took a data set, this was all user sourced, I think it was like 3,500 images we started from on different diseases. And we were able to train a model that would segment out the instance of an individual pod in a picture and then tell you, is that pod healthy or is it diseased, and which disease is it from the image as well. And then the last use case I'll give, again, these are actually banana trees. We were not looking at fruit in this case, but actually looking at the individual trunks of the trees. So you can see as they're walking through the forest, the model that we were able to derive, and we can then take very specific measurements of how many trees are there, what are the size of the trunks. And the trunk diameter is actually a proxy that's used quite a bit for carbon estimation of how much biomass is in that tree, and as a result, how much carbon is it sequestering on an annual basis. I said last example, I actually have a couple more. So we've talked about the field. I want to step back and think about how we're using this also in the development of genetics. So we're working in greenhouses to do things like use machine learning models to estimate the amount of defoliation on these are Chinese cabbage plants. If you look at the video that's moving through here, what we're doing is we're actually reading a QR code on each one of those trays. That tells us the ID of the plants that we see in the cell. But then we train the model to, you and I can look at the first plant and say, yeah, there's pretty much no defoliation there, as opposed to the one on the far right, you can say, well, there's pretty much no plant there. But how do you rate 70% defoliation or 30% defoliation? It's a much more subjective process. So this was actually a linear model that was trained to be able to look at plants, and just from looking at the image of that plant alone, be able to determine how much vegetation is left there and make it more of an objective score versus a subjective human score. And then the last one here is this is taking the same corn plants that you saw in a field setting, but again in a greenhouse. So walking along green plants in a greenhouse, capturing a video that turns it into the 3D model that's on the right-hand side. I'm not really giving you the full experience because it's interactive. You can literally go in, you can view it from different angles, you can take measurements on it, or we can actually do automatic extractions here. So in this case, we've pulled out each individual plant that they look like halos, but those halos are our identifiers showing where the plants were that were extracted. And from that, we can have very specific measurements of things like the height of the plant, the canopy volume, and turn that into something that, you know, a researcher, someone that's developing new varieties can quantitatively assess and start to see differences, hopefully sooner, and maybe even differences that otherwise wouldn't be visible to the naked eye. So I went through that really quickly, but with that, I appreciate your chance to share a little bit about what we're doing, and we'd be glad to chat now or take any questions or chat further in the mixer that follows.
Question for Dr. Vick?
So what examples do you have on return on investment for an end user?
Yeah.
Like an agronomic problem?
So the question was, what are the examples we have of return investment for an end user? And I think right now, candidly, we're a little bit early for some of the end stage farmers, but where we have seen specific return on investment is using this with seed and input providers on their R&D setting. So very specifically, the stand count assessment that I gave you. Typically, they would take say a 1 meter sample of plants in a 30-foot plot just because of the time restriction that it would take someone to count that entire row. We can capture an entire row in about a 20-second capture. So we're capturing about 10 times as much data in probably a third of the time. And we're able to get numbers that match theirs at above 95%. And I don't even call that accuracy because we don't necessarily, the manual is not necessarily the truth here. It's just the comparison point. Where we're seeing returns starting to happen on the farm side, the cocoa example that I gave you, we started with that company very specifically with their R&D team. We were helping them take measurements of very subjective readings that they otherwise had a hard time putting a score around. We have now seen that progress into production applications. So we're working with their integrated pest management team, for example, to build a custom application. The inputs are based off the models that we generated in R&D setting, but they're now being able to put that into practice with their production teams that are going out and scouting things like diseases or pest problems. So that was a little bit harder to quantify, but we are still, it's a progression that we've been able to see of taking something that came from very specifically in the R&D space and seeing it now applicable in a production scenario. And at the end of the day, with almost all of those customers, it comes down to how many assets do I have and what is the forecast of that crop going to be? When is it going to be ready? How much of it do I have ready? And being able to help them make decisions in a quicker fashion. Thank you.
What's your process to work with the faculty individually or group based for projects?
Sure.
And are you open to sharing, for example, data or your R&D firm for some other data collection possibilities or your LiDAR system?
So we're definitely open to working with researchers, faculty, university setting. As I mentioned, we have some collaborations with faculty here, but at other institutions as well. The first entry point, the app is free to download. You can download the app and you can take data capture. Where we sort of put the wall up, if you will, is when you upload data to our system and start to run analysis. But we have an entry tier that's, I think, very affordable for individual users, all the way up to enterprise tiers that we use with commercial clients that we're working with. So, for example, we have a number of like field agronomists that are doing university studies that are wanting to use this technology. Some of them are like, well, I'm not 100% sure I'm going to completely move to this yet, but I want to take this side by side with the data that we're already capturing, and we want to compare it and see how it works. So we have our models in general are broadly accessible. You can use the models that we've developed for another client. You can use that same corn model on your data. However, if there is a specific need, for a customer that says, we need a very specific model that's just trained on our data, we don't want other people's data convoluting it, then we can segment off those products as well. But our general philosophy is we would prefer to build better models that pull data from a broad distribution of customers versus bespoke models that are just, you know, for one user or one set of conditions. Thank you.
Right now, we'll thank both our speakers. And I want to thank all of you again for joining us today. I hope you enjoyed the program. And so from here, we're welcoming you to a mixer up in the lobby upstairs. So if you want to come up and have some drinks and some snacks, we can continue discussions up there. Thank you.